Hello, we're going to take notes 8 on domain and range of functions. We've been practicing domain and range already, but this is specifically on function graphs. Just as a review, domain goes with the inputs of any function, and it goes with the x values. We reviewed this in notes 7. So the domain is the inputs and the x values. The range then are the outputs and the y values. This is important to know and to memorize. So domain is x, range is y. You're going to hear me say this over and over and over as we practice this. Domain, x, range, y. Okay, so we're going to practice finding the domain and the range of two graphs right now. If you could just do your best to sketch these in your notebook. It's going to be a little bit hard. If we had been in class, I would have printed them out for you, but we don't have that opportunity right now. So you're going to do your best to sketch these in your notebook. And we're going to calculate the domain and the range. So for the first one, and I mentioned set notation a little bit during class, our last class. But set notation, we use braces to help us identify the sets. A set is just a list of numbers. And this is called a continuous function. It's continuous because do you see how this graph continues the whole time? There's not breaks. This is a continuous function. We'll talk about the opposite of a continuous function in class. But for a continuous function, it's connected the whole way, so it's a smooth curve. The other one is called a discrete graph, but this is continuous. And the domain then, this is tricky. This is hard work, just so you know. The domain are the x values. Domain goes with the x. And we're going to write inequalities here to help us identify the domain. The domain starts here at the x values start at -3 and it goes all the way to 1. So the domain goes, let me get a pencil here. The domain goes from here all the way to here. So my domain goes from -3 to 1. And that is an inequality. X has to be bigger than 3. X has to be bigger than -3. And X has to be smaller than 1. Now, this is why we learned about compound inequalities earlier this year. This is, remember, a conjunction because it's the word and. I'm graphing the points between -3 and 1. -3 is the smallest, 1 is the biggest. Now, notice this was an open circle underneath. Can you see how that was an open circle if I scoot this over? It's an open circle. So if you look at my answer, it's not underlined. This is a closed circle, so it is underlined. Now with the continuous function and with all conjunction functions, we can, remember, write it in that smushed together way. So I could flip this around. -3 is less than x, and x is less than or equal to 1, and I can just smush them together. So -3 is my lower boundary. That's kind of what we can call it. It's the lowest number. It's my lower boundary is less than x, and x is less than or equal to 1. This is my domain. Continuous functions are hard to find the domain and the range. The range then, remember, is the y values. How tall is this function? The domain goes with how wide it is. Wide. How wide is the function? The range goes with how tall the graph is. So this graph, if we look here, I can get a different color maybe. Here's red. The lowest point here is at -4. And it goes all the way up to this point. That's the highest point. So my range goes from